Our next speaker is our artificial intelligence expert, not the speaker of the year, but the artificial intelligence of the year of the IDBBN. And he's leading our data excellence team, or have been leading that for 1 year. And we are having many interesting pilots going on regarding of the machine learning. And Matti Airas will tell us some more. Put your hand together.
Yeah, so my name is Matti Airas, and it's a really thankful task to present something much more boring and kind of day-to-day stuff that you're facing after Antti's wonderful presentation. So I have a rather bad start. I have a rather strong statement to make, which means that the way we run marketing is going to change. It very much echoes what Antti said, is that once you start making decisions with data, you're not going to go back. I have to immediately also say that doing this is not easy. It takes effort. You have to take that elements of AI or take that basics of machine learning in Stanford to get a feeling of what this all is. But this will fundamentally change marketing. And they were just talking about what year is it now in predictive marketing. Somebody will say, well, this is maybe when the first proof of concepts are on. That's not true. In the US, most companies are already doing this. In Finland, people are now considering first proof of concepts. We're already behind the curveball here. So what is predictive marketing? It is, okay, I'm going to read it. It's a never read your own slides, but I'm reading it because it's very important to have an understanding of the basics. So predictive marketing is a marketing technique that uses machine learning and visual analytics to determine which marketing and sales activities have the highest probability of succeeding. So what's really important here is the highest probability of succeeding. This part, when you've been doing marketing things, you repeat things that you might have been doing for decades or at least years. Now you're going to be able to do things that you know that have a chance, and if you even know what is the chance of succeeding, because once you run a machine learning project, you have a probability. You have a measure that tells how accurate your predictions are. And please feel free to tweet these and put in LinkedIn. We greatly appreciate that. Okay, I'm doing the same mistake as Matti. So I have 3 things here. And Antti sort of took the need to talk about the first one away. But if you have data, and I know all of you, I mean, who here doesn't? Lift your hand. You don't have a CRM. Who doesn't have a CRM? Who has a marketing automation system? Who does web analytics? We have data. I mean, that's not the problem here. The problem is not the data. Everybody has data. The problem is, of course, data quality. But when you have data, it is always better to use an algorithm than not to use an algorithm. It doesn't mean your first project will be humongously successful. It's a path you learn by doing. Analytics actually isn't that expensive. We have great tools, Google, Microsoft. There are a lot of open source libraries. That stuff is already there. The problem is the 80%, getting your data into a shape that you can even use machine learning and visual analytics. And I'm going to be repeating this, so if you're going to get a little bit bored, then don't tell me. Okay, so why is algorithm, when you have data, algorithm is so much better than no algorithm? It's because data is doing stuff that you cannot do. I mean, the algorithm is doing stuff that you cannot do. It's literally like, it's expanding your team's cognitive abilities. It's like a one tireless team member more They work 24 hours a day. They never ask for a raise, and they get better over the time. And if nothing else you learn from my presentation today, just try to, because if you get this, you get what machine learning is all about. So first you have a question, and this is narrow AI. So we have a specific question. We don't have one AI, one machine learning that knows all this. We need one for each one of them. We might even need one for each product. So is prospect likely to buy next quarter? So really specific question. We have a time frame. We want to know whether we move a lead into a sales and spend some expensive sales cycles on that lead. We get together, we take data. We take 60% of that data and use that 60% to teach the machine. So if you know about traditional programming, so traditional programming works so that you have a requirements management, then you code something, and then something comes out, and you're not quite sure what comes out. Machine learning is different. So you know the input, which is the data, and you know the output, which is the customer bought something or didn't buy something. And then the machine figures out the logic. That's the essence of machine learning. And that's why I think people are so scared of it, because people don't code it. It's the machine that figures itself the rules within the data, the patterns within the data that bring the outcome. And then once you've trained it, we always test with data that the machine learning model has never seen. So, and then from this test, we get a figure, like how good is this model at predicting the outcome from that specific business case or business objective. So it's narrow AI, specific question, teaching, testing, and then driving future cases, deploying the model into your CRM or in your MA, and then the model will tell or trigger activities, tell what kind of campaigns to run, move a lead to a sale if it's ready for that. Automation is wonderful. The problem with automation is once you've automated, you've taken the step in utility. You've taken the step that makes your operations more powerful. So if you have, for example, an algorithm that checks overdue invoices and sends the invoices, then it'll do that forever. It's not going to get better. It's just going to keep repeating what it already does. No. The thing is that once you combine the automation with machine learning, you can come with processes that forever get better. So you have more data, more training cycles over time. You might have in the beginning an accuracy of 80% of prediction in one case, and then let's say 6 months later you might be at 85, a year later you're at 90, and suddenly you really start trusting your predictive model. And then you don't have this case anymore where an old sales guy comes to you, I know better, here's my own call list, just like Antti said. And that is going to be your problem. There are going to be salespeople who are going to tell you, I do not trust your list. And you might need to run some demonstrations to them that, why don't you start, just try, just call the 10 first numbers on this list. Just, you know, for my benefit. And once they start really trusting that, then their behavior changes. And 3 months later, they're going to say, hey, where is that call list? Give it to me. Then to the hard part. The data part has proven out. I've been doing different kind of AI stuff now for about 8 years. No, maybe I started in 2010. So 8 years, yeah. And it's hardly ever the analytics is the problem. The problem is almost always the data, or in the other end, once the analytics is done, it's the deployment. So what happens, the model is done, it works well, its predictive quality is sufficient, but it never gets deployed to the field for operational reasons, for integration reasons, for culture reasons, who knows? So those are often much bigger problems. So what is predictive marketing data? It is, again, have to say, it depends, but it has to reflect the reality. So the data has to describe the actual behavior. So if you're doing lead scoring, which is the probability that the customer will buy, then you have to have data that has to do with the purchase path of the prospect. It also has to have some master data, so static data about the contact and the company. And the last one, I just added this yesterday, there it wasn't there, but we've had lately a lot of problems where the customer does a data retrieval project, and suddenly we notice it ends at March 2018, and we're now in October. Guess what happens if we build a model using data that ends in March right now with the prospects that have, that it's not anymore relevant. So it has to be up to date, the data. And this is also interesting. So if we go into other analysis like churn analysis, then it's not just about the purchase journey, just MA, web analytics data. Then we also need data about something very interesting that came up with one project was product use. We didn't actually have in the churn analysis ability to know if the customer had used the product at all. So it's hard to say customer leaves, but we don't know how much they used before they left. So did they actually leave it because they hadn't been using it? Or did they leave it because the experience was bad? So maybe there was some reasons behind, and in this kind of cases, it's very hard to do reliable churn analysis if you're missing key pieces of information. This is especially super interesting when you have a software business, because in software business, you do know whether a customer is using it. You know how many logins are there, and you know how many minutes they've been using it. You know which modules they use, and so forth. But funnily, often this isn't even thought about in the churn analysis. So when I started with IDBB and I read these papers which said 80% is data preparation, 80%, I was like, no, I don't think so. I mean, you just go, you offload some data, and then you do the analytics. I was totally wrong. We've sometimes taken months to get here with the data, and sometimes we've taken 2 days. It really depends what kind of shape your data is in, and how many systems do we have to download it from, how can we make the rules of downloading it consistent, that we're absolutely sure that the data from one system to the other is comparable. It happens exactly in the same time frame and so forth. But the data preparation is really, really difficult and takes time. And often we've noticed that that's where we failed in the projects because we haven't given it enough time. Business objective usually, of course, figuring out the business objective is difficult, but once we sit down, it's pretty clear. We have a churn, we have 5% of product A users churning every year. We want to reduce that to 4, and it saves us X millions a year. And then we set a goal, we set a clear target, reduce churn, and set a way to measure it. Then we get an understanding of the data. We extract the data, we prepare the data, and this is why it's so difficult to prepare the data. The machine learning requires that the data is in certain format. For example, it often cannot be in time series format. It has to be in a format where basically, if all of you know Excel, all the rows are contacts or companies. So in churn analysis, companies, in lead scoring. So if you have transactional data, we have to transform it into that kind of data. There's usually a lot of empties. I've never seen a data set where all the behavioral data is there. So we try to fill in blanks. If there is big enough percentage of data there, we can use machine learning to fill the blanks because we know enough about similar companies. So we use them to think that, okay, because this company looks like this, and this company looks like the same, and it has an empty field, we can populate that field with the value that is close to value that should be there. But right now we have a strong feeling that it has to be in the range of 70 to 75% fields have to be filled before we can reliably start predicting the empty values. So if you have 20%, 30% fields filled, it's difficult for us to use it in the model. Often there are values that are way out of whack. And those values we get rid of because they just distort the overall analytics. And of course, we try to make it as consistent. This is the big part. And we just had a project where actually we had 9 attributes, so 9 data fields. And in Excel, you can think of these as the columns. But at the end of the model, we had 60 fields. So we generated, out of 9 fields, 51 fields more because we wanted to know for each of the 9 fields, the first date that transaction happened, the last date that transaction happened. We wanted to have a mean, we wanted to have an average, so we built a model that was much more complicated than the actual data set because the actual data set didn't produce the results, and suddenly we were able to get the results much more accurate. Grouping, so if your variables have, or attributes, oh, sorry about the confusing you with this, but basically I'm always talking about the Excel columns here. So if there are a lot of those values, we have to try to group them because machine learning, if you have too few hits for a value, it isn't able to use that in the analytics. So it's very, very important to group them, but to group them in a meaningful way. So we spend a lot of time with the customer talking about these things, that we get it into a structure that reflects, again, the reality. And then, of course, in the end, we try to then look at which variables actually correlate strongly with the outcome, and then remove the ones that correlate too much, because there is this, I'm going to talk a little bit more about this, but there's a problem in machine learning of not using variables or attributes that affect the outcome too much. Again, I'm too technical. I'm really sorry. Ask questions in the end. And these are, I just wanted to have like 5 basic issues that we faced in our projects that go wrong. So first one is that we have incomplete data, or the data doesn't reflect the reality. So if you have an objective of trying to figure out lead scoring, and we're missing all the web analytics data. So we don't know at all like how many web visits they had and what websites. We only know like how many forms they downloaded and things like that from Eloqua. It isn't enough. We want to have the whole path from the first time they came to your site to the moment when they bought. And we also need CRM transactions into this system so that we can get the whole thing. So the data has to reflect the objective. This is really, I already talked about it, but this is really weird. I thought that wouldn't be a problem. But when people extract data from different systems, it often happens that somehow they are from different time frames. So if we do a machine learning model, the data has to be from the same time frame. Of missing values, I already talked about. Attribute noise is an interesting because we had a project where we had a lot of attributes, and the results said that, oh, this model is working great. And then we tried to apply it, and it was actually not good at all. So there was a statistical thing happening that each attribute had a very small factor, but they all pointed in the same direction. So it wasn't a good model because there was this but we found this mistake, and these are the things we've learned in these projects. And then dependencies. So each attribute should be as independent as possible, and the outcome, for example, whatever the salesperson is doing shouldn't affect too much. So whatever you're using in the analytics should come really from the customer's action, the customer's behavior, the customer, who they are. So this is also something. In the beginning we thought that we could also include a lot of factors about the behavior of the company, but they actually affect the predictive quality, so we had to reduce those. This is something we've been now discussing for quite a while, so At the end of the day, you might say whatever now, and your IT and BI people might be against it, but you're going to have to do this. It's not something that you can postpone it maybe and offload the data from your operational systems, but there comes a time when you just cannot live without a data lake. And data lake isn't a data warehouse. I know we all had those massive data warehouse projects, especially in about 5-6 years ago, and a lot of them failed. And they had very different kind of thinking behind them. They had a strong structural thinking and a strong governance thinking. These are more like lakes that flow a little bit over the edges. These are not well defined. So use schema on read. Does people know who knows what schema on read is? Okay. Who knows what a relational database is? Structured. Okay. So this is not a relational database. It's basically a place where you dump all your data, and it doesn't have to be structured. It's a lot cheaper to run, and you build the intelligence of the reporting on top of it. And there are great, great benefits. I mean, we've already seen projects where some of the platforms keep data such a short time that you just lose it. If you don't store it somewhere, it's gone, and you can never go back there. I think this one truth already came up in Antti's presentation pretty well. So you have to have one place where you do your reporting from. We've had many projects where we've had problems offloading data from systems, and the reason is that the platforms don't want so many people contacting it and loading it with processing time. So we are trying to avoid using the operational systems to do stuff that we can do elsewhere. So this is not something you start a project today, make a really simple, talk to BI guys, make a really simple plan in the beginning, but this is where you need to go. And it doesn't have to be pretty, it doesn't have to be perfect in the beginning. This is not some massive IT project. And in the long term, I promise this will be cheaper. Because then you have this one place and you build the ability to report, run machine learning project, all of it from this one location of data. So the most powerful thing about the predictive marketing will be that you will know every day more and more about your customers. It will be a forever increasing and deeper understanding of who your customers are, how they behave, who they are, what kind of companies they work for, how are their companies doing, are they growing, are they laying off people? I mean, all this data needs to be included there. You need to know what percentage of your customers, for example, and this comes not just machine learning. Once you have this data, you can do all kinds of stuff with the data. Like you need to know how many people, for example, that buy from you have at all been on your website. It was shocking to see in one case where a company was investing a lot of money on really cool websites and landing page and everything, but the truth was that the most sales transactions happened totally outside of that funnel. It was the old-time sales guys calling and the website was there, and less than 10% people visited the website. So you need to know what's happening. What are the things you need to do? And once you start getting your data together and you start improving it, you start having more machine learning projects. The machine learning projects force the data to be better. It's a really good cycle. And you're going to be able to use it for more stuff. So when we talk about predictive marketing, we talk about actually not that many things, but pretty fundamental things. So how do I make sure that our customers don't leave? So churn analysis here, so customer retention. I couldn't figure out, so I just put you don't want your customers running away. You can use it so usually one of the key things in machine learning is you need to teach it. So this company is a customer, this company is not a customer. This company left, this company didn't leave. This company bought that product or this portfolio of products. So you have also the ability not just to do this kind of binary on-off type of, but you can also do categorical things with machine learning. So if you have categorized your customers into segments, you can use that data to teach the machine learning to categorize new customers into segments. And interestingly, it will categorize them better than you can because it's taking into account stuff that you possibly can't even imagine is related to that outcome. Account-based marketing, so right now the only thing we're doing there, of course you can use all the other ones for account-based marketing, but in account-based marketing, one really critical thing is recognizing buying teams as early as possible. So how do I know that these 5 people belong to the same company and they're working together to make a big purchase decision? And there we can use AI to help that. Cross-selling, upselling, of course, and then the biggest things, lookalike targeting, which means you create profiles of your customers, and then you use third-party databases to find companies that look like your current customers, and then target those companies. And lead scoring, I have a case study. I'm going to talk about lead scoring. But to us in IDBBN, the machine learning isn't the trick. The trick is how do we combine machine learning with the traditional marketing? I mean, how do we combine machine learning with the marketing automation? So our view is not that it's just a tool that helps you run better marketing campaigns and better marketing programs. So this is extremely simplified picture of a traditional marketing automation. So you have an idea, you decide the personas, goals, you decide the content, somebody decides the content, you decide who you're going to send it to, you have a list, you configure it, and then you run. So this is going to change quite a bit once you run it, and we call it the predictive marketing program. So right then you start with the business objective and a target. Let's say that right now your salespeople are making 1,000 calls a month, and out of those calls, 10% of them are effective. So then you start thinking, well, what if we were able to focus on those accounts that are more likely to turn? So let's not make 1,000 calls a month. Let's make 500 calls a month and still have the same outcome. So you would have massive savings in sales. Of course, you can double the amount of good calls for a salesperson. We actually have a project right now where the lead scoring is really going to be used for prioritizing the calls. So start from the top, and then if you have time, and then you walk down the list and do the last ones. So you have an objective, and we want to also measure. So this is really important. So when we set, let's say, this kind of target that reduce churn from 5 to 4%, then we set ways to measure it. So once you have the program running, we want to know that it really happened. That was the objective. And this is the visual analytics part also. So you want to make sure that whatever you intend to do in this program happens. And it's not just wishful thinking, you don't know in the end. So first, you have the objective, and as I said previously, the objective tells what data we need. So if it's lead scoring, you need certain data. If it's churn analysis, you need certain data. If it's cross-sell or upsell, and so forth. Then we push this data, once it's all prepared and beautifully put in the right shape, we put it into our machine learning process and visual analytics process. And from there, we get 2 things out. We get a list of people that this should be targeted to, and it's a dynamic list because we can run this all the time in the background. You can run it weekly, you can run it monthly. So basically, it's a forever automatically updating list for people that this objective is targeting. And we find out what things are driving what things we can come up from the analysis side to find out what's really driving that behavior. So, and once we know the themes and topics, you have really data. You're planning your content and messages based on what you know about customers, not your intuition and artistic skills. Of course, you still need all the creativeness of beautiful videos and all that, but you have a much better understanding like what messages resonate to the end crowd. So 2 things. It automatically updates who you should target, and it tells you the reasons for the analysis results. Then I have one case example. This is a company, it's a B2C lead scoring case. So this company sells a product that is rather expensive for consumers, so it's a big decision. It means that people take time to research, they go to competitor, all kinds of web pages, they want to find out a lot about it. But they had a good problem on that side, or a good thing on that side. They were generating a lot of leads, so their lead generation is going very, very well. The problem is they had a manual lead scoring system, so they had themselves given weights to different activities that consumers did, but the results were not useful. So they couldn't trust. The results were, they felt like it's not something we can use. And what ended up happening, sales was making a lot of calls that didn't lead into deals. So we took their CRM and web analytics data and drove it all into our machine learning. And we scored all the leads from 0 to 100 on likelihood. And right now, we're still in the middle of the process. Actually, we have a meeting this week to start figuring out on the next phase. The first results indicate that the conversion is going to go up 3.8 times. So they can make 75% less calls and still come up with the same amount of sales. It's a massive change, and it's a massive cost saving. And people ask, and this is really ugly, and it's because we use, who has heard about R? Okay, so R is this statistical programming language. It produces horrible looking charts, but it's very, very informative. So we use Tableau for simple things, and when Tableau just doesn't cut it, we use R. So here is an actual buyer and a predicted buyer. And when we started analyzing this and we ran the machine learning project, we noticed that every time a person bought, there were clusters of behavior in certain time windows. So we started being able to predict like what kind of behaviors in what part of the, and these are just one example. This is one person, this is one person. So once we start looking at it as a whole, we start getting a clear understanding that this sequence of transactions between the customer and us leads to a deal, and this sequence doesn't. So customer thought this was even cooler than the actual scoring, because then they can start figuring out what works and what doesn't. And then, of course, when we take all these, we can see which activities then have more power and what less. So what does it take? So we've now run, I think, 5 projects with 3 different customers, and it has been difficult. But the difficulty has never been on the machine learning side. The difficulty has all the time been trying to get the data right, trying to get the data so that it doesn't have too many empties, trying to get the time frames right. So the data, I mean, I can't emphasize enough, start improving your data quality today. And as Antti said, it will never, ever be perfect. And the nice thing about machine learning, it doesn't have to be perfect. It can tolerate a lot of inconsistencies and missing fields and so forth. But it has to be good enough for it to work. So you have to have a measurable business problem. So you have to have something that you can set, like we increased this 2x compared to this in this time frame. We reduced churn by 2% on this time. So it has to be something very precise. So it kind of changes also. Of course, marketing campaigns have goals, but they're more like goals like we want to have 10,000 new leads. This goes more into measuring really the financial, all the way up to the financial benefit. And of course, that has an indirect financial benefit. But here we're really trying to go down to the concrete benefits. And the nice thing is often that the same stuff we use to teach the model is the same stuff we can measure the outcome, the success of the outcome. So often we don't need any additional data. But crucial part here is that it means that your sales data we need to get your sales data at not necessarily product level, but at product group level, in order to do this stuff. You have to have a detailed deployment plan. And what I mean with that, if, let's say the model is perfect and it's ready, what are you going to do then? Where are you going to put that model? Are you going to connect it to your CRM to trigger sales activities? Are you going to put it into your MA to trigger emails? What are you going to use it for? What is the end use case for that machine learning model? We've started in the beginning projects that we were just, hey, let's start machine learning. Nothing good came out of those. We need to really know, why are we doing it? Where is it going to end up? What business process is going to improve? This is something I know is very difficult for a lot of you, because you don't want us necessarily to access your data. And this is a problem that goes away once you have the data lake. But we've noticed that the projects where our data experts, and we have one member in our team that does nothing but data extraction and storage. So his job is really to try to get the data. I understand that you probably don't want us to access all your operational systems, but we've noticed that if we have access to the data, the projects turn out to be better. And if you download the data and then we download part of it, then we've got to be really, really careful that it's consistently done. Right skills, that's like the minimum thing what you need. Because in every project you need all those skills. And some of those skills are easier to get, and some of them take quite a while. So, for example, latest project, we had to build a script in Python, and it turned out to be like a piece of almost like software code. It became so big because the data was so complicated. So it actually requires quite a lot of... but the last one is most important. So you have the reality. What happens in real life? What happens? Does that reflect the data? And what do we have to do in the data science side to keep this chain working so that we don't break it? And if you're missing something fundamental in the reality versus data, then the predictive quality of that model is never as good as it would be if we had that piece of data. The nice thing also, of course, in this is you can start with less and then improve the model over time when you have some new data available. But then that I can say that almost if you have data, any predictive model is better than humans' ability to predict. And it's because your businesses and your data sets are so complex. So we have a team. It's called Predictive Marketing Lab. We right now have 4 members in the team, and then we have, of course, the magic Mr. Rhythm, who works tirelessly. And I am absolutely convinced that once we start doing predictive marketing, your business will get better. But there are no quick wins here. This is a new skill, and like any new skill, it takes time to acquire. So you have to start somewhere. The process can be really small in the beginning. We're not talking enormous investments here. You start somewhere, and you start getting better. And the nice thing about once you start using one data, I know a lot of companies have problems between what marketing does and what sales does. How do you synchronize their activities? Once you have data and you have machine learning, and a lot of the silly arguments between what works and what doesn't work go away because you have a way to tell how things are working. You have the probability of success there. And you can go to the salespeople and you can start bridging the gap and making sure that the salespeople are triggered in the right time so that they don't waste their expensive hours on bad leads. One thing that I've learned, I've interviewed many machine learning and AI companies, managers, and I've seen many offers and the way how they work. We don't want to work like a black box. We will tell you. We will tell you what algorithm we used. We will tell you how we manipulated the data. We will tell you every project you will have basically a report that's pretty long telling exactly what we did. So this way your organization will learn with us. And of course we have a sort of a selfish objective because we want you to tell us how to improve it too. And once we make it transparent and we document everything, then we can work together to come up with the best possible solutions. We use very secure ways of storing and moving data. So most of the analysis and things actually run in the same place where Eloqua runs. So things are never taken out of Eloqua servers. For those of you that use Eloqua, if you're using something else, these things can be run anywhere. We don't care. So if you want to run on Amazon servers, we'll run on Amazon servers. If you want to run on Azure, we'll run on Azure. So that's about the safety. Plus, you have to remember when we do things, we almost always anonymize everything, or at least pseudonymize. So we don't know who they are, those people. We don't have their email addresses. We don't, because the analysis, we don't care. Once you move it back to the marketing automation platform, then of course there it needs to be matched. The ID needs to be matched to the email address, and you can actually work the real stuff. But in the analysis, we don't need to know who these people are. And in the end, I have a little announcement. So we have made a deal with Demandbase about the top of funnel activities. So who knows what Demandbase is? Okay, so Demandbase is one of the world's, probably Gartner now named it the leading targeted advertising platform. And the cool thing about them, they have an enormous database of company information. So basically, they're an advertising and lookalike targeting platform, and they have all the tools for the top of the funnel activities. So if you're interested to talk more, go to their website or contact us, and we're happy to talk about them. But they're a company that works before people come to the landing. They solve most of the problems that happen before they come to the landing page. So they drive traffic and advertising, and they have all the interfaces to the advertising networks. They also go to the content side a little bit, but they are more really in the lookalike targeting and display ad type of world. Thank you.